Alright, I'm going to do this quick. So we have the first 4 problems. I do this in Paint. Okay, first one, this crosses the y-axis, that's x comma y, at positive 2, so the equation is y equals 2. For this one, this crosses the x-axis at negative 3, so this is x equals negative 3. Okay. For this function, a linear function usually looks like y equals mx plus b, where b is your intercept, your y-intercept, and then m is your slope. Okay, so it's going to be y equals, our slope is going to be up 1, that's our rise, and then our run is 1, 2, so it's 1 over 2 x, and then our y-intercept, where it crosses the y-axis, that's at negative 1, right here is the y-intercept, so minus 1, done. Quadratic functions look like a parentheses x minus h squared plus k. So to find your a value, this is a quick way. You go from the vertex, start at the vertex, and you go right 1, up 1, 2. Okay? You went right 1, however far that you go up on your first jump, that is your a value. So it would be y equals 2, parentheses. Actually, looking at this, our vertex is at the origin. That means there is no horizontal shift, so there is no h, no horizontal shift. There is no k, no vertical shift, so it would just be 2x squared. Done. Looking at 5 and 6. Okay, for 5 and 6. This equation, again, a is right 1, down how many? So you go from negative 2 to negative 1, and if you go down, you see that the graph crosses right there. And that is approximately, actually it's halfway between 0 and negative 1. Whoops. So because it's right 1 down a half, your a value is a half. Okay. So it would be y equals negative 1/2 because it's going down. This is a horizontal shift. It's shifted from the origin to the left 1, 2. And the horizontal shift is always backwards, so it's x plus 2 squared. And since it doesn't go up or down the vertex, there's no k value, so your answer is done. Okay, again, a value from the vertex, always from the vertex, not from the origin. Left 1, up 1, 2, 3. So your a value is 3. In parentheses, you have x. So your horizontal shift, this is where you go from the origin. Your horizontal shift goes right 1, so you put minus 1 in parentheses, always opposite, squared, and then your plus k comes from your vertical shift, which goes up 1, 2, plus 2. Okay, so next one. This is m, absolute value of x minus h plus k, where m is your slope. So to find your slope, start from the vertex. Slope is always rise over run. Rise over run. So from the vertex, it rises up 1, 2. So rise over, it runs 1, 2, 3. So 3. Absolute value of x. Now we handle our shift. Our shift, it starts at the origin and it goes right 1, 2, 3. So it's right 3. And down 1, 2. So minus 2. Next problem. Our slope from the vertex, it goes down 1, 2 over 1. So our slope would be negative 2 over 1. but negative 2 divided by 1 is just negative 2. So it's negative 2 absolute value. This graph was shifted from the origin. The vertex goes right 1, 2, up 1, 2, 3. Okay. 10. These are exponential functions. Exponential functions are a little different. B to the x minus h power plus k. K is what is referred to as your, make this bigger, asymptote. Okay, that's what k is. K is your asymptote. Okay, so there's two really important points. We're going to call this one right here the first point. We're going to call this one the second point. Okay, and we want to make sure we do our asymptote. Our asymptote is the line that just runs underneath the smallest point, just like that, and it crosses at 1. Okay, it crosses right there. So for our asymptote, that's at positive 1. I'll just put plus 1 right now, save myself the trouble later. Okay. So this first point should always be 1 above the asymptote. Okay. Your next point, however far this point is above the asymptote, not the axis, the asymptote, that is your b value. So if this goes 1, 2 above the asymptote, it's 2 to the x power. And again, h represents your horizontal shift. There is no horizontal shift. This first point is on the y-axis like a good point, so you just leave it. You're done. For number 10, again, let's identify these two important points right here. And let's make our asymptote. Okay, asymptote's right about there, maybe there. It's a thick line, so it's kind of weird. So, start off with our asymptote. This equation will be a plus 2, because that's where our asymptote is. Right here, that's our asymptote. Okay, and then we have to deal with the rest of our stuff. Our base, this second point is 1, 2, 3 points above the asymptote, so our base is 3. And then x. So remember, this first point right here, it's supposed to be on the axis. It's not on the axis. It actually got shifted right 1. So that's where you put the right 1 shift. Okay, next. 8 minutes in, not too bad. Okay, we want to solve for y, get y by itself, so you add x to both sides. So 2y equals x. Get y by itself by dividing both sides by 2. Y equals x over 2. Since there are no parentheses, that means that there's no horizontal shift. There's no plus k, so there's no vertical shift. So our first point starts right here at the origin, right there. Right there. That's our first point. So this slope right here, it's rise over run. It's rise of 1 over 2. So you're going to go rise 1 over 2, put a dot. Rise 1 over 2, put a dot. Rise 1 over 2, put a dot. And because it's a linear function, you would connect these all with that same straight line as best you can. Okay, and they go on forever. So that goes on forever, that goes on forever. So when doing domain and range, your domain, okay, domain is always left and right. So the leftmost part of our function is right here, that has an arrow, that means that your lowest part of your domain is negative infinity. Okay, so now the rightmost part of your domain, over here, again, you have another arrow. So this would go to positive infinity. Okay. Oh, whoops, whatever. Okay. So now we're going to talk about range. Domain is left and right, so that means that your range is going to be up and down. Your lowest point goes first. So the lowest point of our graph is right here. Hey, would you look at that? It's an arrow again. So negative infinity. And then over here on the right side, that's the tallest point of our graph, the highest point right here, which means that it goes to positive infinity. Whenever you see an arrow, that means it goes to infinity and beyond. Buzz Lightyear. To get y by itself, the opposite of positive 2x is negative 2x. You subtract 2x from both sides. So y is left over. You can't combine these. These are not like terms. This does not have an x on it. Therefore, you cannot combine these. So it's just negative 2x plus 1. So our vertical shift is right here at that plus 1. So we're going to start our graph at plus 1 right there. And this is a negative 2. You can turn any number into a fraction by putting it over 1. So this slope goes down 2 over 1. Down 2 over 1, put a point. Down 2 over 1, put a point. Down 2 over 1, put a point. Down 2 over 1. Okay. Connect them all with a straight line. And I'm trying my best. I think that's okay. Close enough. So for this one, domain and range. Domain's left and right. The leftmost part of our function, it's an arrow. So that goes negative infinity. The rightmost part of our graph, it's another arrow. So that goes to positive infinity. The range is up and down. The lowest part of our graph, arrow, negative infinity. The tallest point of our graph has an arrow, positive infinity. Okay, all done. Next one, to graph this, first handle your shift. Your shift, this is right 1 because it's opposite. Inside the parentheses, their horizontal shift's always opposite. So it's right 1, up 2. That is your new starting point. Okay. So to find our pattern is typically a times 1, a times 2, a times 3, and a times 5. 1, 3, 5. So since our a value is that negative 1/2, that means that this is negative 1/2 times all these numbers. So negative 1/2 times all these numbers, negative 1/2 times 1 is negative 1/2. Negative 1/2 times 3 is negative 3/2. And negative 1/2 times 5 is negative 5/2. So from this point, you go right 1 down half of a square. Okay, then you go right 1 down 1, 2, 3/2. Let me make this a bold arrow so you can kind of see it. Come on, man. Okay, close enough. So it goes right 1, down 1/2. Right 1, you're going to go down 1, 2, 3/2. Okay, because this is in halves, you have to travel by half squares. Right 1, down 1, 2, 3/2. There's your point. Right 1, down 1, 2, 3, 4, 5/2. Right there. And you do the same thing on the other side. Over 1, down 1/2. Over 1, down 1, 2, 3/2. Over 1, down 1/2, 2/2, 3/2, 4/2, 5/2. And there's your quadratic function. Domain for this function. Again, left and right. Left part has an arrow, negative infinity. Right part has an arrow, positive infinity. Okay. Now your range. Your lowest part of your graph. They're both arrows, so that means negative infinity. The tallest part of your graph is up here, and since range is your y values, that's at positive 2, so you put a 2, and this gets a bracket. Because it's actually equal, this point is 1, 2. It's equal to 2. So that's why you put a bracket. If this was an open circle right here, you would not put a bracket. You would put a parentheses, but it's a closed circle. For 14, there's no horizontal shift, there's no parentheses, so that's your only shift right there is that negative 3, so down 1, 2, 3. That's your starting point. And again, you got a times 1, a times 3, a times 5. Okay. So our a value is in front of x squared. It's always in front of x squared. That's our a. So 2 times 1 is 2. 2 times 3 is 6. And 2 times 5 is 10. So these are the numbers that you're going to use to find the rest of your points. You're going to go right 1, up 2, put a dot. Right 1, up 1, 2, 3, 4, 5, 6, put a dot. Okay. You would go right 1, up 10 for the next one, because that's your pattern, but 10 would be off the grid. So we'll go back to here. Left 1, up 2. Left 1, up 6. Okay. And there is our graph. Okay, don't be afraid. Don't freak out. I'm just turning off the game thing. There we go. Alright. So domain and range. Domain. On the left side, leftmost function's an arrow, so you put negative infinity. Rightmost is an arrow, positive infinity. Range. The lowest part of our function is down here at negative 3. So you put a bracket, negative 3. And then the tallest points are both arrows, so that means that that is positive infinity. Okay, more graphing. Okay, so this function's actually written backwards. It's that way to confuse you. Negative x plus 4, and then that's a positive 2, so that goes last. So our shift, that is a left 4, and that is an up 2. So you go left 1, 2, 3, 4, up 2. That is your starting point. Okay. And whatever's in front of the value, that is your slope. That is a negative 1 over 1. So you go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and just keep doing that to get all of your points. But since this is an absolute value bar, that means it's an absolute value function. Absolute value bars are always V-shaped. So from here, you go left one, down one, left one, down one, left one, down one. Okay. And here are your points. There you go. That's your absolute value graph. Let's not forget the arrows. Domain. Left side's an arrow. Negative infinity. Right side's an arrow. Positive infinity. Range. Your lowest point is an arrow, so that's negative infinity. Your tallest point is at y equals 2. Positive 2, put a bracket. This next function, there is no horizontal shift, there's no number inside the bracket, but there is a vertical shift, that's at positive 1. Okay, so positive 1, and then this right here is our slope, that's m. So it's going to be, our slope is 2, make it to a fraction by putting it over 1, up 2 over 1, put a dot, up 2 over 1, put a dot, up 2 over 1, put a dot, up 2 left 1, put a dot, up 2 left 1, put a dot, up 2 left 1, put a dot. There's our absolute value function. It'd go on forever if I let it. Again, domain, negative infinity to infinity. Okay, left arrow, right arrow. That means there's your infinities. Your range, remember it's tallest point, lowest point. Lowest point goes first. Your lowest point is right here at negative 1. Tallest points are arrows, so that means you put infinity. This next one. Okay, usually you'd have a plus k. There is no plus k here. So that means that your asymptote is at 0. This is your asymptote right here. Okay. So your first point is typically located at the center and it's one above. However, there's this guy right here, which means shift it right. So shifting right, there's your first point. To find your next point, you would use your base, which is right there. So that is 2 above the asymptote. And your graph is an exponential function. Like that. So for your domain, left side, there's an arrow. Right side, arrow. For your range, lowest part is the asymptote. That's at 0. The graph never touches the asymptote, so it gets a parentheses, not a bracket. And the tallest point has an arrow, which goes to infinity. Okay, plus 1. That's our asymptote. So plus 1 gets our asymptote. I would do a dotted line, but I don't know how to do it on Paint. Sue me. Just kidding. Don't do that. Okay. So, and then here, this right here, this number is our base. That's how far it is above. Sorry. The first point is typically always 1 above the asymptote, which is right here. But there's a shift going on, which says you go right 2. So instead, we go right 2, and there's where our point should be. And then our next point, our base, that's how far it is above the asymptote. So right 1, up 2 from the asymptote. And there is our function. Yeah. Whoops. Yeah, there we go. Okay, 19. So this says between -1 and 2. So I can only graph this function between these 2 points. Okay. Okay. So at -1, I'm gonna put a point or like a line, so I know not to graph on the left side of that point. And at +2, can't graph on the right side of that point. There. Okay. So here's our function. There's no horizontal shift, no vertical shift, so it starts at 0. And our slope is 3/1. So you go up 3/1, put a dot, up 3/1, uh-oh, we're hitting our boundary. So this is where you determine if it's a closed circle or open circle. So since this is the boundary right here, that's the symbol for a closed circle. If it has a line underneath it, it's closed. So we put a solid circle right here over the dot, call it a day. Okay. And if you were to go in the other direction, okay, down 3, left 1, you hit this, and this symbol has no line underneath the inequality, so this one would be an open circle. Okay. Oh, I was hoping to get rid of those lines. That sucks. Can I erase stuff? Don't want to erase all of it. Select shape. Can I select this guy? No. Oh, that's kind of cool. Alright, well, it looks like I'm out of luck. Okay, but anyways, your final graph would connect this dotted line with the rest of the lines, and you'd have to make sure that you don't put these vertical lines on your test because that looks bad. Okay, but that's kind of to help you to draw. You do not graph outside of this. This is your restriction. You can only graph this graph between -1 and 2. So between -1, +2, that's where my graph is. Okay, 20, we're going to skip 20. 21, F2. So you have to look at these and figure out where it belongs. Is 2 less than -1? No. 2 is greater than or equal to -1, so you plug it into this function right here. So it's 3 to the 2 plus 2 power minus 4. That's 3 to the 4th power minus 4, for a grand total of 81 minus 4, which is 77. -2 is the same thing. -2 is less than -1, so you are going to plug it into this function. And you got to follow order of operations. So 3 minus 2 parentheses -2 plus 5. You cannot add these. If you do that, you are breaking your dear Aunt Sally's heart. Do not subtract these first. You cannot do it. So it's 3 minus 2, absolute value. -2 plus 5 is 3. And 2 times 3 is 6. And 3 minus 6 is -3. And the last one, -1 is not less than -1. It is either greater than or equal to -1. So you're going to plug it into this function. So it's 3 to the -1 plus 2 power minus 4. Or that's 3 to the 1st power minus 4, which comes out to -1. Okay, so you should be able to do 22 after seeing 21. We'll check that together in class. I'm starting to get sleepy. It's 12:30. Grumpy old man. Okay. So, two functions. We have two functions here. We have a function here, and we have a function here. We graph the first function on the left side of 0. So, positive 2. You go to positive 2, and you graph it all the way until you get to 0, and then you stop. This would actually be an open circle here, because it doesn't have the or equal to symbol. But the second function has greater than or equal to 0, so this function, if you were to plug it in, this function starts at positive 2. So at positive 2, you would override the open circle, and then follow your slope of negative 1 over 1. So down 1 over 1, down 1 over 1, so on and so forth. And there's your graph with arrows. Okay, so domain and range. Domain, arrow on the left, negative infinity. Arrow on the right, positive infinity. Range, lowest point, it's right there, negative infinity. Highest point, your highest point is all this region right here. That is as high as your function will ever get. And that's at positive 2. Done. This next function, it says 3. That's your restriction. So I'm going to go to positive 3 on the x-axis. Put a little line down to remember myself not to do it. Okay. Come on, man. Shouldn't I be able to pick this thing? Okay. So this is your function. You can draw this on dotted paper with your pencil, or dotted line with your pencil. Okay. So I'm gonna graph this function first, and this is only on the left side of 3. So right 1. So I go right 1. That's my starting point. It goes. The follows the pattern a1, a times 3, a times 5. And since a is just 1, that's the number that's in front. Since there's no number in front, it's a 1. So it's going to be right 1 up 1. Right 1 up 1, 2, 3. But since it's on the x value of 3, you have to put an open circle, because it says strictly less than. Okay? And it follows the same pattern on the other side. Okay, so there's the first one. The second function starts at negative 1, so negative 1, but you cannot, for any reason whatsoever, put down any points yet. So start at negative 1, and it goes up 1 over 1, up 1 over 1, up 1 over 1. Here's where you can put a function value. Okay, that is right here. So now it says greater than 3, up 1 over 1, up 1 over 1, up 1 over 1. Okay. So our domain. Okay. Our leftmost point is negative infinity, but there's a hole right here. There's a hole in our graph at positive 3. So from negative infinity to 3, and you're going to join that with a union symbol from 3, which is our leftmost point on this section of the graph, to positive infinity over here. Three-parter, 0, 0, 3. Okay. So x squared, start at 0. Left one up half a square. Left one up 1, 2, 3 halves of a square. Left one up 1, 2, 3, 4, 5 halves of a square. So the function looks something like that. Okay. And it's a closed circle because it has the or equal to sign right there. It says it's 1 between 0 and 3. So at 0, I put an open dot at 1, because that's like saying x is 0, y is 1. And it goes like that all the way until you hit 1, 2, positive 3. Since it has the line, that is a closed circle. Okay. So this has an asymptote of 0. It usually starts at 0, 1, but because of this guy, we have to shift it right 1, 2, 3. So it actually starts from this point right here. It starts from this point. And you go right 1, up 2 from the asymptote, and this function is your exponential. So domain. On the left side, it's negative infinity. And as you trace the graph, what happens is you get right here, and there's a little jump. But since there's this open or closed circle right underneath the open circle, it's okay. You don't count that as a discontinuity in your domain. So it's negative infinity to infinity. And your range, lowest point is right here at 0. And it's a closed circle, so it's going to be a bracket. Highest point goes up to infinity. Okay. So less than negative 3, you go to 3. So 1, 2, open circle here to the left. X squared minus 2 between negative 3 and 2. So that is going to be from this point to this point. So start at negative 2, because that's our starting point. And then x squared has an a value of 1, so you follow the 1, 3, 5 pattern. Right 1 up 1, right 1 up 1, 2, 3. And since this has the less than or equal to symbol, you put a closed circle. Left 1 up 1, left 1 up 1, 2, 3. Left 1 up 1, 2, 3, 4, 5. And this last one is a linear function from 2 to 5. So starting here, you go up 1 over 1, up 1 over 1. Now you can start putting dots. Up 1 over 1, up 1 over 1, up 1 over 1. Stop, because you cannot go past x equals 5. It says so right here. And that would actually be an open circle. So domain is from negative infinity. That's your left part. Even though there's an open circle here, right above it, there's a closed circle, so it's okay. The rightmost part right here is at 5, and because it's an open circle, it's parentheses. For range, your lowest point is down here at negative 2. Tallest point is up here, and that's at 1, 2, 3, 4, 5, 6, 7. So that one's done. Okay. Write an equation that represents the linear function on the interval. I'm trying to figure out what I haven't done so far. Okay, reflections. Okay, from the first part of me doing it, you should be able to do 27, 28. Okay, we'll do these guys. Okay. So this function says go right 2, up 3. Right 2, up 3, put a dot. And And this is a 1 in front, so you follow the 1, 3, 5 pattern. So it's right 1 up 1, right 1 up 3. Okay. So here's the deal. This says f of negative x. This means that you're going to reflect over the y axis. Okay. So if it says negative x, you go over y because you're changing x values. So this point comes over here, this point comes over here, and this point right here is 1, 2, 3 away from the axis. And this point up here is 1, 2, 3, 4 away. So you go 1, 2, 3, 4 away. So that's f of x, and that's f of negative x. Okay. Over here for number 30, g of x and negative g of x. The negative is in front. If the negative is in front, that means that you're going to go over the x-axis. Okay. So this is left 4, down 2. Left 1, 2, 3, 4, down 2. And negative 1/2 means down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Alright. And connect them. Okay, there we go. So this function is g of x. Okay, to flip it over the x-axis, this is 1, 2, 3 points below. So we go up 1, 2, 3. This point is 2 below, so you go 2 above, right there. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. So 1, 2, 3, 4. Okay, and you get the hang of it. And that's negative g of x. Okay. I'm going to skip these two. I'm going to skip those two. Alright, let's see. Alright, almost done. I'm just going to do 35 and 36 and we're going to call it. Okay. So, f of x is this function right here. So, f is first, so I write f. 3, but when instead of writing x, I'm going to stop and I'm going to replace x with g of x in its place. So instead of x squared, I write x minus 4 squared. With 36. That's an ugly 4. Okay, for number 36, this was a typo. There should have been an f. Okay, so for f of x, it's 1/2. I want to find f of g of x, so I write 1/2, absolute value, stop right here. I do not write the x. I have to replace it with g. So I put x minus 2 instead, plus 2. Okay. This function is right 4, 1, 2, 3, 4. And we follow the whole A1, A3, A5 pattern. So it's really 3 times 1, which is 3. 3 times 3, which is 9. 3 times 5, which is 15. So it's right 1, up 1, 2, 3. Right 1, up 1, 2, 3, 4, 5, 6. It gets really big. So this function is just really skinny. Yeah. This function over here. So it's minus 2 and plus 2. So minus 2 means we're going to go right 2. Plus 2 means we go up. So right 2, up 2, put our point. And this is up 1 over 2 for our slope. Up 1 over 2. There's our function. Sorry I skipped some. I got tired, but hopefully this is enough to help out. Good luck. If you have any questions, please bring it up to me before you take your retake. Much appreciated. I'm going to bed.